Hi, I'm John. In this chapter, we're going to give you an overview of how the machine is controlled and a very basic introduction to the programming language we use to tell the machine what to do when it's cutting a part. As we saw in the first chapter, a typical CNC lathe has a turret that moves right to left as well as in and out. The spindle is what spins the workpiece and the turret holds the cutting tools. The two directions of movement are called axes, and they move like this. The Z-axis moves left to right, and the X-axis moves in and out, or you could think of this as up and down. The machine coordinate system defines where the axes can move, and it's how we measure how far they've moved. It basically tells the control where the turret is inside the machine. On most lathes, home position for the Z-axis is here, on the far right side. As the turret moves away from this position, you can see that the Z-axis position readout is getting more and more negative. We can say that we're moving in the negative direction. If we stop here in the middle of travel and start going back the other way, we can see the position readout is now getting less negative. Now we're moving in the positive direction. Home position for the X-axis is all the way up, and it acts the same as we saw on the Z-axis. As we move the X-axis down towards the center line of the spindle, the position readout becomes more negative, so we're moving in the negative direction. Now, as we move back up, the readout becomes less negative. Now we're moving in the positive direction. Now, if you watched our mill operator certification videos, we talked about the work coordinate system and that you could think of the machine like the GPS map on your phone. The machine coordinate system could be thought of as the map where all the streets and landmarks are around us. And the work coordinate system might be our physical location within this existing map, based exactly on the street corner that we're standing. In a basic sense, the machine coordinate system defines the size of the world inside our CNC machine, and the work coordinate system defines where the important starting points are inside that world. But with a CNC lathe, the center line of spindle rotation does not move relative to the X-axis, so there's not much need for an X-axis work offset. The cutting tools are clamped in the turret here. The workpiece rotates with the spindle here, but otherwise doesn't move inside the machine. The turret holding the cutting tools does move inside the machine. We need to tell the machine where each cutting tool is compared to our workpiece. We do this using the tool offset page. Now, when you're starting out as an operator, your supervisor will be setting up the job and they will set the tool length offsets correctly. But we're going to show you the basics of how it's done so you have an understanding of the complete process. I have my workpiece clamped in the chuck. I command the spindle to rotate at 500 or 1000 RPM, and I jog my first cutting tool, tool number 1, close to the part. I take a skim cut on the face of the workpiece and press the Z-face measure button. That sets the Z-axis tool offset for tool number 1. Next, I jog to the diameter of my workpiece and, again, take a little skim cut. Without moving the X-axis, I jog away from the part and stop the spindle. I take a measurement of the diameter I just cut and press the X diameter measure button. The control asks me what the diameter is, and I enter the value I just measured. This sets the X-axis tool offset and teaches the machine where that tool is in relation to the spindle's center line. There are several ways the setup machinist can set the tool and work offsets precisely. If you have a probing system on your lathe, it's faster and a little more accurate than what we just showed, but the basic principle is the same. We won't go any more in-depth on offsets for now. Just understand that until these numbers are entered correctly, the machine doesn't know the location of the part or the tool. As we saw earlier when we were using the machine coordinate system, as we move away from our home or zero location, the machine position increases in the negative direction. But now that we've defined where our part is with tool offsets, our workpiece can now be viewed as our zero position. We just need to make the tool number 1 offsets active and change the program display. Now the control will show our position relative to the workpiece. As you can see, Z0 starts here at the face of our workpiece, and jogging in the Z-axis, anything this side of the part is negative. And anything in this direction shows us positive. The same is true for the X-axis. The center line of spindle rotation is X0, and as we move away from center line, all the coordinates are positive values. The interesting thing about most CNC lathes is that they display the X-axis coordinates in diameter coordinates and not the actual distance moved along the X-axis. Diameter coordinates are actually 2 times the actual distance moved. The reason for this is because the workpiece rotates about the spindle center line, but our cutting tool stays on one side of the spindle center line. I'm going to hold my scale here, stationary against the workpiece, with the end at the spindle center line, which is 0 in the X-axis. Now watch the readout on the control as I jog the X-axis. You can see that I jogged the X-axis 2.125 inches, but the amount on the display is showing 4.25 inches, twice as large as the actual movement here on the scale. The coordinate display makes sense because I'm cutting a 4.25 inch diameter. When we look at the drawing of the part, it specifies the dimension as a diameter. So it's less confusing to program the X-axis to move to 4.25 to cut a 4.25 inch diameter than it is to program the X to 2.125 inches to cut a 4.25 inch diameter. This allows us to program using numbers directly from the part drawing. So now we have a general idea of how the machine moves and how it knows where the tools in the workpiece are. We need to tell the machine where to move and what to do when it's time to start cutting a part. That's what G-code is all about. G-code is a common language people use to tell computerized machine tools how to make things. G-code is basically a list of instructions saved as a program that tell the machine exactly what to do, like what tool to use, how fast to spin the workpiece, how fast to move the machine, and where to move to do the cutting. A G-code program looks like this. We'll look at a few of the most common G-codes so you can get an idea of how this language works. Now, although you will always hear a machinist refer to this language as G-code, there are actually 2 basic types of function codes that are used when programming. There are G-codes and M-codes. G-codes tell the machine how to behave or what to do, and the M-codes are more like switches that turn a function on or off. Both G and M codes can have letter address codes that provide more information or instruction to the machine. These letter address codes are letters and numbers that come after the G or M code that give the machine all the information it needs about a particular function. For example, the code M03 is the command to turn on the machine spindle in the clockwise direction, but it doesn't tell the machine what speed to rotate the spindle. The letter address S is the speed command, so we would program M03 S1000 to rotate the spindle clockwise at 1000 RPM. Another M-code example is M08, which is the command to turn on the coolant pump. The code M09 will turn the coolant pump off. These two M codes don't require any extra address codes since they simply turn the coolant pump on and off. Now, here's an example where we just use the address code on its own. The letter address T indicates which tool to put in the cutting position and which tool offset number to use with that tool. For example, the code T101 commands the machine to rotate the turret to put tool number 1 in the cutting position and to use offset number 1. To use offset number 11 with tool number 1, we can command T111. To use offset number 11 with tool number 11, we would program T1111. So, let's look at how these codes interact with some motion commands from a typical program. We start by telling the machine to change to tool number 1 and use offset number 1. Then we move to the next line. G97 tells the machine to read any S command as revolutions per minute. Again, M03 turns the spindle on clockwise, and S2000 is 2000 RPM. G00 is the command for rapid motion. This tells the machine to move at its fastest possible speed to the position in the address code. So in this case, the X and Z axes move from where they are to a 4.25 inch diameter in the X axis and 1/10 of an inch in front of the part in the Z axis. Next is the G01 command. G01 tells the machine to move in a straight line to a new position at a specific speed. Z-1 inch is the coordinate we're moving toward, and the F address code and the .005 value specifies the feed rate, or speed at which we'll be moving, in inches per revolution. The Z-axis will move .005 inches with each revolution of the spindle. You might have noticed that we're defining our feed rate differently than we do on a CNC milling machine. When milling, we typically specify the feed rate, or the speed the axis is moving, in inches per minute. On a CNC lathe, we typically specify feed rate as inches per revolution when turning. There's a good reason we use inches per revolution on the lathe. Doing it this way means it doesn't matter what speed the spindle is turning, whether it's 100 RPM or 1000 RPM, the feed rate will remain .005 inches per revolution. This means as my rotating speed goes faster or slower, the distance the cutting tool travels will change with it. So I'm always cutting the same amount of material per revolution no matter what RPM I'm running. In a simple sense, most of the motions that a CNC machine makes are based on 3 codes: G01, which is the motion command in a straight line, G02, which defines circular motion in the clockwise direction, and G03, which is circular motion in the counterclockwise direction. The machine is capable of producing extremely complex shapes using just these 3 G codes. So, we've taken a quick look at how a CNC lathe moves along its 2 axes. We talked about the machine coordinate system that defines the size of the world inside the machine. We demonstrated setting the tool offsets to tell the machine where the workpiece and tools are located inside this world. And lastly, we looked at the basics of how we program a CNC lathe to move and cut parts. Currently, there are around 200 G codes and M codes combined in the Haas control, so obviously we're just barely scratching the surface of all the different ways you can control the machine using these commands. But as you become more familiar with how CNC programs are written, you'll come to understand the functions these codes perform. And since there are so many codes you can use, we've made it easy to get help remembering what all of them do. Press the Help key while in memory mode and scroll to the G code or M code headings and press the Enter key. You'll see a complete list of G&M codes and the explanation of each. You can also refer to the list in the operator's manual. That's it for now. Thanks for watching, and we'll see you in the next lesson.